Blockchain is a database or a ledger that is shared or distributed across a peer-to-peer network of nodes. Nodes are just computers which run blockchain software. The big innovation with blockchain is that it guarantees the accuracy and the security of data. And by using code, blockchains generate trust without the need for trusted third parties. The main difference between a more traditional database and a blockchain is how the data is structured. A blockchain collects information together in groups, which we call blocks. These blocks hold sets of information. Blocks have certain storage capacity, and when they're filled, they are closed and linked to the previous block. This forms a chain of data known as the blockchain. Any new information that comes in after a block is closed is compiled into a newly formed block that will then also be added to the chain. A database tends to structure its data into tables, whereas a blockchain, it structures its data into chunks or blocks that are tied together. It's this data structure that makes a reversible timeline of data when implemented in a decentralized nature. When a block is filled, it's set in stone and becomes part of this timeline. Each block in the chain is given an exact timestamp when it is added to the chain. The goal of blockchain is to allow digital information to be recorded and distributed, but not edited. In this way, a blockchain is the foundation for immutable ledgers. This means records of transactions cannot be altered, deleted, or destroyed. Imagine a super large company and it requires 20,000 computers to maintain its database. This database holds all of its client account information. Now, the company owns a warehouse building that has all these computers under the one roof, and it's got full control of all of these computers and all of the info that is within these computers. This, however, provides a single point of failure. What happens if the electricity at that location goes out? What if the internet connection is lost? What if it burns to the ground? What if a bad actor erases everything with a single keystroke? In any case, the data is lost or corrupted. What a blockchain does is to allow the data held in that database to be spread out across several network nodes at various locations. This not only creates redundancy, but also maintains the fidelity or the accuracy of the data stored in them. If someone tried to alter a record at one instance of the database, the other nodes would not be altered and so would prevent bad actors from doing so. If one user tampers with Bitcoin's records of transactions, all other nodes would cross reference to each other and they'd easily pinpoint the node with the incorrect information. This system helps to establish an exact and transparent order of events. This way, no single node within the network can alter information held within it. And because of this, the information and history, such as of transactions of cryptocurrency, are irreversible. Such a record could be a list of transactions with cryptocurrency, but it could also be possible for a blockchain to hold a variety of other information, like legal contracts, state identification, or a company's inventory. Because of the decentralized nature of Bitcoin's blockchain, all transactions can be transparently viewed, either by having a personal node, which is just a computer connected to the network which is running the software, or you can view a transaction using blockchain explorers. These allow anyone to see transactions actually occurring live. Now, each node has a copy of the chain that gets updated as fresh blocks are confirmed and added. So that means if you want to, you could track Bitcoin wherever it goes. For example, exchanges have been hacked in the past where those keeping Bitcoin on the exchange lost everything. While the hacker might be entirely anonymous, the Bitcoins that are extracted are easily traceable. So if the Bitcoins that were stolen in some of these hacks were to be moved or spent somewhere, it would be known. Of course, the records stored in the Bitcoin blockchain are encrypted. This means that only the owner of a record can decrypt it to reveal their identity. And this is done using a public-private key pair. As a result, users of a blockchain can remain anonymous while preserving transparency.